Welcome, students, to another video lecture with Mr. Connect. So we're on our final section of Chapter 1. I hope your practice of taking these video lecture notes is going well at home. Let me know if you have any questions or concerns in class. So I'm going to ask you to pause here before I move on, and please copy down what you see. Remember, it's important you do copy down what you see as it is, indentations and all. Go ahead and pause here and copy down. Okay, welcome back. So our essential question in this last section of Chapter 1 is how do we determine whether to use tables, equations, or to use graphs? And what I'm going to try and do is show you this trend from how it could have started with words, and our goal is to get it all the way to graphs. And the heading is not misleading. We're gonna go through words, equations, tables, and then graphs. So like most of our word problems, we're learning how to circle those things we care about in the problem. So you should try and interact. Go ahead and take a second and circle what you care about in this problem. Awesome. If this wasn't enough time for you to circle everything, pause, continue circling before you see the answer. So our first words we care about, I think, is this distance is equal to 60 miles per hour times the number of hours. Oh man, that's a lot of circles. My goodness. That's okay. We're going to make it into a simple equation. So you don't have to write any of that down. Go ahead and just write this equation heading down. We'll get to the table part in a second. So translating this from left to right, we're going to have B for distance, we don't know the distance, is equal to 60 miles per hour. So the miles per hour is the unit for this number 60. So we're going to put 60 there. Times. Do we have to show a dot for times? No, because we're just going to put the number of hours there, and that's our last variable. We actually have an equation now with two variables. How many of you think you could have created that equation? D equals 60h. Distance is equal to 60 miles per hour times hours. Awesome. So we created this equation. Now our next task is to try and see what this equation creates. And the easiest way to do that is going to be in our table format. And I'm going to teach us to use that T-chart process a lot. Our first column is D, and we have a D and an H rather than an X and a Y. And I actually reverse that. We should put the independent variable, the thing that the other one relies on, the independent variable in the X column. And we should put the dependent variable in the Y column. And if you don't understand this independent and dependent I'm talking about, we will continue to use these throughout the class. But independent means it can be all by itself. So like in this problem, you are not really able to find the distance unless you know the number of hours you started with. We could solve for an hour based on a distance provided, but the independent part is time, the number of hours that go by, determines the distance we've actually gone. So time is independent, distance is dependent. Now we have to select some values. And just like before, when we get to choose numbers, we should choose easy numbers, not our favorites. So in this case, the first time we want to know how far we've gone is actually with a time of 0. So we're going to substitute 0 in for the H to figure out what D equals. So just like when we have been practicing, we should write it down. Then we substitute with our empty parentheses, and we're going to stick the number 0 in there. Now we're just following the order of operations. What's 60 times 0? Yep. The D for this one equals 0. So at 0 hours, we have gone 0 distance. I know, pretty surprising, huh? What is the next number that's pretty simple to substitute into a math problem? Yeah, it's a 1. So I'm going to draw a little squiggly to segment this part off. And now I'm going to substitute in with the number 1. And you're going to notice I still wrote the same formula again. I'm still writing empty parentheses where that variable is that I'm substituting for. And 60 times 1, oh, well, that equals 60. So what we're really doing here is we're creating ordered pairs based on numbers we're choosing. We're going to choose one more number. I'd love you to perform this math for, what's an easy number past 1? Yeah, you're right, it's 2. I know, overwhelming, huh? And again, we're going to model that. And you have likely recognized there's now a pattern to this. That's awesome. But we want to put it on a graph to make sure. So we're going to jump ahead here. Notice my graph I've started to create is just going to be a y-axis and an x-axis. Go ahead and pause here and get this axis here with a little bit of space. Hey, welcome back. So, as I was mentioning, time is independent. So we're going to place time, the h variable, on the x-axis. And we're going to place the distance, the d variable, on the y-axis. Now, what number did we count by when we did the hour change from one section to the next? How much are we counting by each time? 1. So on our graph, it's going to be good to start counting by ones. And remember, it only takes 3 numbers to show a pattern. So once we've shown the pattern, you can assume that pattern continues. What I'm modeling here is I didn't just choose ones. I looked at the table first to figure out which numbers I should count by. So let's go ahead and look at the D column here. How much are we counting by each time we go from one to the next? Yeah. So since we're counting by 60s consistently, what we may want to do on our axes is count by 60 also. And you may have noticed I actually jumped 2 lines before I wrote it. That's okay as long as I'm consistent. This first double jump is 60. The next double jump is 120. Then 180, and I do not have to show any more numbers because we assume now, based on the pattern I showed, we're counting by 60. One thing I've learned is some students get confused where 0 is. So I'm hoping everyone recognizing that this is the ordered pair, 0, 0. It's the origin. Now that we've created our axes, we've added some numbers, let's get our ordered pairs on there. Our first ordered pair is 0, 0. Now our next ordered pair is 1, 60. Our third ordered pair is 2, 120. Now, as long as you did on graph paper, and you're about to do this next part with a straight edge, the reason mathematicians like to graph results is by using just these 3 results that we figured out, we are now going to be able to graph the line that has all of the results. So start with your straight edge and connect all of these. And you're going to go well beyond the ordered pair. We're not playing connect the dots here. We're creating a straight line that goes through all the dots. So again, we're not connecting the dots and stopping on the third. We're going on. Because now, if I was to ask you, how far have we gone at 5 hours? All you would have to do is go up to the line and find out that we've gone 180 plus 60 is 240. We've gone 300 miles when we've moved 5 hours. So this is why mathematicians and scientists graph, is with a small piece of the ordered pair pattern, we can actually find the infinite number of solutions that actually exist. So moving on, we're going to have 2 more examples after this problem. This was like my guided model. So go ahead and draw a squiggly line underneath this example. And I'm going to show you the 2 more problems to copy down. And when I show them to you, please make sure to leave space because we need room to work these problems. So here are our last 2 problems for our video lecture, example 2 and example 3. Make sure to leave space after example 2 in this region, because we're going to need to do all of these substitutions in this space you have provided down here. If you have any questions, like always, put them in this question column. Let me know what you may be asking. I'll try and help you out as we go. Thank you so much for having another video lecture with Mr. Kinnett. I'll see you soon.